Nic Daley is going to do a short presentation. He made a few slides. One of the big questions we have is how Voxes find each other, how they talk to each other, given that they don't all have domain names and they have to authenticate to each other. This whole problem of how do we talk to people when we don't quite know where they are, we don't quite know who we can trust, is one of the major issues that we're trying to address, not just in this project, but a lot of other projects too. So Nic has made a stab at this problem, which we call the magic routing problem. Because every time we encounter it, we just sort of wave our hands and say, by magic, the routing will work out. So Nic is going to try to turn that magic into something that actually works. He's done some work on it. Isaac has done some work on it. So he's going to tell you what he has done, and maybe that'll move the conversation forward, hopefully for everybody. Nic Daley.
Yeah, let's see if this works. All right, so the biggest issue that we have right now in a lot of our communications is that we don't think of people, computers don't think of people as people. If I tried to tell you who I was on the internet, I would probably end up giving you about 40 different links to this website, to that website, to this Twitter account, to this Gmail account, etc., so on and so forth. On the first slide, we sort of see the structure of the system as I'm kind of imagining it. Of course, this has been preempted a little with a discussion we had today, but catching everybody up never hurts. There are three basic systems involved. On the left of the screen, you see the messaging UI. That's the last one I'll come to. It sort of describes how the user interacts with the system. Toward the right of the screen, you see the identity system, which communicates with the messaging UI, as well as gets its identity information from that big DHT circle at the top, and also communicates with the routing layer beneath it. The routing layer is actually the only part of this that communicates directly to the internet.
What is DHT?
Distributed hash table. That's basically a collection of identity information, like a directory. The yellow pages of the internet, if you will. Doesn't have to be a hash table. There are a couple different formations it could take. We were talking about this morning. But that's a tried and true structure, particularly for BitTorrent and so forth. They've done that really well. As far as the identity service goes, on the next slide, the goal is to be a self-verifying identity directory. I, for example, could publish a statement that says, hey, this is my blog, hey, this is my Twitter address, hey, this is my homepage, and I can sign that statement with a GPG key. It's basically the verifiable signature of the internet. Anyone can create any key, pretty much like anyone can, forge anyone's name on paper, but it uses what we call a web of trust, saying, hey, do I trust this person to validate this thing for me or not, to actually say whether you can actually trust this signature. If it looks forged, if I, for example, wrote James's signature in all capital letters and he uses cursive or something, people would say, hey, what's up with that? And that's trying to enforce that verifiability for identity. There are a couple ways it could be implemented. It could be, it's probably going to have to use a web of trust, which builds upon the GPG web of trust. It could be done through a distributed hash table. It doesn't have to be. There could be friend-to-friend searching, which would be an incredibly interesting approach to this, but it doesn't have to use only one source. There are a couple of limitations, the first of which is that it's probably not globally accessible. It'll be accessible to folks running FreedomBoxes, folks running services through FreedomBoxes, but I don't think that's one of the Zuko problems that we experience through Zuko's triangle. I think with pet names that I'll get to in a minute, we can actually square the triangle, for lack of a better phrase. We can use this setup to map our web of trust to a hierarchical, centralized set of trust, such as, SSL, X509 certificates, but we can't rely on that hierarchical trust. To that end, I'd like to point everybody to the Crossbear website, and they recently released their Firefox extension a couple of days ago, along with some terrifying admissions that the folks running the SSL system, pretty much put out forged certificates for the purpose of spying, which was an exciting experience to read. Routing, next slide. That's on the bottom. Again, the part that connects directly to the internet. I assume at this point that folks are using pet names. What pet names allow are giving a user meaningful name to the identity statement. If I say, hey, I have my blog, my Twitter account, et cetera, the computer knows this as a whole bunch of numbers. I think mine ends in like 9223A or something irrelevant like that. But users can, it's basically your own personal directory. You can give that a more useful name, like you could say Nick or the crazy guy in the orange shirt, if you felt like calling me that day. The secret is that your pet names are never published, so no one else can ever guess what they are. Your computer should be able to identify people for you based on their pet names. So if you get a message from someone purporting to be mom, but your computer knows your mother is actually called my dearest mother, you're probably not going to be fooled, because you're going to say, hey, this isn't the right name. Again, back to the routing, it's not dependent on one specific backend. It supports it requires whatever backends the identity statements define. So if you say, hey, you can reach me over Twitter, then your box is going to have to actually get in touch with the Twitter network. This is probably the only part of the system that I see that is machine specific. There isn't any really worldwide approach that we can take to this, like, for example, the user directory. That crosses machines really well. So this is the one part that's actually dependent on, the person running the box to give you the communication methods you need. It's modeled after Namecoin's NC Proxy and another number of related similar projects. And advancing to the next slide, we finally get to the user interface part of this, where pet names actually identify people. I can say, instead of sending a message to X Twitter account, I could say, send a message to man in orange shirt. And thanks to our other two abstractions, that of the identity layer and the routing layer, the system can automatically route the messages pretty much magically. The user, for example, the idealized user interface here is the user writing a message, the user picking a list of recipients, and the system going through the recipient's preferred methods to receive it and picking out whatever one can transfer the message the best. For example, if I were to try to, tweet a full-length movie, it's not going to work pretty well. But if I want to tweet to Isaac, or if I want to send a message to Isaac involving a full-length movie, the system could look at, hey, Twitter's not going to fit the bill. Let me see if I can email it. No, probably won't work. Let me just publish a link to, my list of files and email that to Isaac, and it'll get to him. It's trying to take the method selection out of the whole experience for the user, so that the system does the manual thinking in that sort of way for the user. Routing is based on the services the identity supports, that user's preferences, and any constraints, as I mentioned a minute ago. The conclusions here on the next slide. The first two abstractions exist in large part for the third. The identity and routing layers are great by themselves and probably fairly important, but we aren't using them fully if we don't bring that simplicity back to the user. Any service on the FreedomBox should be able to use the identity and routing services. Routing could certainly function as a proxy from, mapping a name to any IP address or a hidden service and so forth. The messaging service is basically that magic front end that everybody keeps talking about that we have like 3 or 4 examples on the user interface page, I think. And it's trying to rework communication for people instead of computers. And finally, I don't think anything that I just brought up is actually new, but I don't think it's been done well before. I don't think it's been done in an open, extensible, usable manner before, and that's the important part. And on our final page, you'll see the references where I can cite things and prove I'm not just crazy. We have Crossbear's release notes, Entangled, which is a distributed hash table for Python, the Namecoin, a couple of proxies, and my personal posts on the matter. Are there any questions that anybody has? Did I explain anything well? I hope. Okay.
So any service on the FreedomBox should be able to use the identity and routing services.
Hopefully.
Do you imagine those then being presented as basically transparent mappings that, this is a LAN or an IP address for the individual, so that existing web services can just
that probably requires reaching into existing services and updating them. It would be fantastic if it could catch, for example, URLs that don't otherwise map and route them automatically.
Right.
But I don't know that that's always going to be possible. I haven't built this out at all yet. It's mostly just trying to get the idea out there. All right. Well, thank you, folks.
I have a question. I just couldn't see. I hadn't worded it in my head, which I hadn't finished. So, barely. The pet name system is machine specific, right?
It doesn't have to be machine specific if the user has a traveling profile. It probably should be machine specific, but it's really user specific. I have my list of pet names.
So you haven't decided if it's going to be machine specific or machine specific or user. I mean, machine specific or the other option, machine specific or user profile that is correct.
It depends on the user's profile backend, how that gets built out. If the user has access to, a number of Freedom Boxes and says, I want my profile to follow me around, then that's great. But I don't think it's the best idea for pet names because we are giving the boxes access to the user's list of pet names, which isn't the best of ideas. Because you're essentially allowing access to what should be a private list.
Right.
much like the iOS address book access trouble that's been going on in the past week, where no one thought it would be a problem to let any app on the device get complete unfettered access to your contact book. And a bunch of them just started uploading your contact book to the central servers as soon as you installed them, because that's private information that people are interested in acquiring.
Who are these people that trust their computers?
Right here.
I'm kidding.
Thank you, Nick.
All right. Thank you, folks.
So that was Nick's thoughts on where we're going with some of this routing. Now he he did that before we arrived here today, and then Isaac and a bunch of other people and Nick sort of did some work on what the DHT might actually look like. Do you want to take a minute and tell people about that? Or
Yeah, sure.
Okay, come on up.
Say a few things. Rarely do I answer no to that question. So, yeah, we were all talking and just sort of thinking what might this system actually look like as it moves towards implementation. And so what we saw in Nic's proposal, right, was this mechanism that allows us to associate identity and sort of routing information, or information that would allow other boxes to communicate with our box with our names. And the idea was that would happen through a distributed hash table. So what I was trying to think about with some folks was, okay, well, what a hash table does, right, is it takes a key value and it gives you, it returns a hash of that value. So it allows you to associate one value with another. A distributed hash table is one that allows you to do that in a distributed manner. So the essential question there is, okay, well, what are you hashing and what's the value? So what's the key value pairing? And what we were thinking was, well, maybe we could do it where the key is your GPG signature, maybe long form, because there are some problems with short signature collisions. So different people can have the same short form signature. So you would the key value would be the long form signature, and then the hash, the value, could be what we were calling the identity schema, which would be your full GPG key plus what folks were calling the Santiago information, this port, basically information that would allow whoever it is that's trying to contact you to open up communication with your device in a secure way to get up to the minute routing information. So, and I'm actually still relatively unclear. I'd like to see what people think. I mean, I'm not sure I've completely understood the concept of the Santiago port, although what I'm thinking of it as here is, right, a port on your FreedomBox that is allowing a Tor hidden service in and out. And that allows you to update very, very rapidly or dynamically, what your address is, where, and not just a single address, but you could have multiple addresses, public and private, of various forms, v4, v6, whatever. So that's actually, I hope I'm not going too far off topic, but this is the other thing we were talking about. I can't remember your name, but Brian and I were talking about routers and router hardware, and this. I've been talking with some folks for a while about a project called Freedom Node, which would basically plug into FreedomBox and help it participate in a mesh network. So, and that would talk to the Freedom Tower, which is basically one of these things. But the reason I bring it up is just that once you were able to communicate with the box over this Santiago port, you would then have, say, a public IP address and a private IP address for this other box. And you could say, oh, crap, well, the public IP address is the same, which means that we're probably on the same local network. So I'm going to try to discover this box's services on my local network. And that way, what we can do is slowly become less and less reliant on upstream communications providers, so that when we are in a community network, in a cooperative network, which I think a lot of us are hoping will emerge and become more popular, then the FreedomBox will enable local exchange, truly peer-to-peer exchange. And by that I mean not just in the logical or abstract sense, but in the material sense, where literally you never have to give your bits to an upstream provider, which I think is the ideal situation. So the cool thing about this schema is that it would make that possible. It is the only reason I bring it up. So basically getting access and thinking that it would be long-form signature hashes to full key plus information for the Santiago port. Any comments, questions, anything?
Who are you distributing the hash table with?
Yeah, so that's a great question. I mean, the way I can see it working is that, like the Free Network Foundation, which is our organization, would help build that infrastructure, and any other volunteer, FSF, whoever, would put up the initial nodes in that community, and then hopefully, right, so like each Freedom Tower, each Freedom Link, like each of those would be a node in the hash table, as well as anybody. I think it could be optional on the box. Do you want to help other people find each other? And hopefully could sustain itself that way.
So you're thinking basically just one giant DHT with smaller nodes underneath it, but something publicly accessible where we're all
a global public one. Because the great thing about doing it this way, right, is that all of that information is information that I think people ought to feel comfortable sharing publicly. Because all it is, right, is it's a signature and a hidden service address. Right. So there's no real exposure there as long as you've got proper access control on the port where the hidden service is coming in. Right.
That actually probably shouldn't be the only approach, though.
You're right.
Because, up until yesterday, I was really entertained by the idea of a global directory. But, if you look at it adversarially and you publish public information, such as, your blog, for example, then you're pretty much just asking to be taken down. Possibly an additional approach that would be wise would be, possibly a friend-to-friend lookup, where the entire DHT isn't publicly available, or at least you're given the option of publishing and routing information only to your friends.
Sure.
Yeah.
And you could piggyback the two.
Yes, certainly.
Much like you have the large, basically the key server network in a DHT, so you've got all of the signatures up there, and if you know anyone in that and can connect with them, they can offer you additional information that's out of band for the large scale public activity, so you don't have to.
There's just no reason to artificially limit the storage of that information.
I think that's a really great point. And I think maybe the actionable part of this, what might allow us to sort of make forward motion, right, is if we can settle on the idea that that from somebody's long-form GPG signature, we should be able to find their key and a hidden service with a particular that's serving up access to information in a particular schema about, here's my full key, here's any certificates that I've signed, here's any address that, whatever, and allocate access to that information dynamically based on what information you have about the person that's requesting it. That, I think, allows us to make forward motion.
If you require requests to be signed, you can actually make that decision then and there based on the web of trust of the requester.
Yeah, I think that would be a good. And the other thing is the the idea that we were throwing around earlier of like using a URL shortener to distribute this information works too, right? As long as you're saying, okay, in order to really find somebody, you need their long form key and their hidden service. You can pack that into whatever carrier of information you want to. You can send it on a carrier pigeon, which is awesome. So I think that could be a workable model where we try to do discovery based on those two pieces of information, and it requires further specification of what this schema would look like exactly. But I think that's moving a step closer to practice.
You could do the rest of that second chunk as a second system of contact management, basically on the box. Once you have the DHT of addresses to establish the secure connection to the box, wherever it is.
Basically, managing your own identity, this is basically the process of managing this on your box for yourself is the same as the process of managing your contact information for somebody else, except you have the authoritative version.
Right.
So, yeah, I think that's exactly right.
All right, let's do that.
That's my spiel.
Yeah. How do you differentiate? Like, who's the central authority to identify what's a security breach, or like, how do you identify a rogue user? Or,
sure.
Like what?
So the cool. So I think the answer there is dependent on which mechanism for discovery you're actually talking about using, because we're talking about something flexible, right? Where you could say, oh, I'm going to try to find them through free DHT. I'm going to try to find them through existing key server infrastructure. I'm going to try to find them through a URL shortener that they stuck their thing into. So, but what I'm saying is in each of those situations, you have a different model for trust. And I think the most interesting one is the distributed hash table, which is the one that I'd sort of like to see our community steward and make really usable. So in that case, the answer is there isn't a centralized authority for trust. It's part of the design, is that,
Right.
yeah.
Is it like PGP?
It's, yeah. Well,
What's the difference between GPG and PGP?
well,
The name.
GPG is an implementation of is the GNU. PGP is pretty good privacy. GPG is GNU Privacy Guard. So GPG is just the GNU implementation of the PGP.
I just wasn't sure.
Yeah.
Sounds
We had a presentation of the isoc-ny from about Kaleidoscope, which is a system for bypassing the Great Firewall of China, where I don't know if it's relevant or not, David, maybe you could address it, of how people could trust the people they were talking to.
Right, there's a trust network in terms of connecting to proxies to bypass the
Cool.
I posted a video of it, so you can find it.
Awesome. I'll look it up.
So how do you plan on protecting this Santiago port if you don't have some centralized authority like service?
Right. So the idea is that anybody could find your Santiago port, and unfortunately, what this would mean, right, is that if we're using Tor to do discovery, then anybody that wants to establish communications with you has to be participating in the Tor network, because you can only communicate with a hidden service if you're running through Tor. So repeat your question. Sorry.
So part of what you were saying earlier was that this hinges on the fact that you can, have proper access control in Santiago, because otherwise all of those credential information about your user are available. So how are you going to protect that if you don't have some central authority mechanism to verify identity?
Right. So I think the idea is that you could, right, by access control, really what I'm trying to say is that you could determine which of these pieces of information you want to give out based on the characteristics of the requester. So for one thing, the requester should sign their request. And then you can or could sign the request, right? So with a signed request, you could then say, okay, I have these friends, right? In a web of trust, because again, we're using PGP cryptography. So you can say, this person has signed. I'm looking at my web of trust to see if any of my friends are friends with the person holding this key. And if they are, then you can say, oh, this is a trusted request. They want to know my v6 address so that they can send me an XMPP message, right? Cool, because they're a friend of my friend. Or in the case where you're just getting started, right, there might have to be some manual mechanism for getting your first trust relationship, and that, I mean, there was a project in our community.
The high five.
Yeah, like a smartphone high five for crypto keys, where it's just like, okay, here's my QR code, and you like look at each other, and then everything else happens. So there could be mechanisms like that for seeding the trust database, but basically what we're saying is that there's no central authority for trust. There's only, who do you trust already? Is the person that's trying to get your credentials part of that web of trust? And that way the trust mechanism is decentralized.
So how would you join then?
So the way you would join is you would, if you don't already have crypto material, which I think at least the people that I'm imagining as the target user base don't, then when you get a FreedomBox, right, there would be some enrollment procedure. I'm talking off, I don't know if this is part of the plan, but there would be an enrollment procedure where you would generate a key pair, and that would be your key pair, and then you could do your first trust exchange at that point, or you know, I think it would also be appropriate for there could be trust providers too. I don't think that should be ruled out, where like you do the enrollment process and then you say like, okay, I want a high level of trust off the bat, so I'm gonna like give my actual legal credentials to a trusted party, and that could be optional. I don't know if that's something that people would want to introduce, but it is something to think about. So.
You would also want, during a setup procedure, to introduce your box to your phone, for instance, or whatever other devices you're going to be using, with a high level of trust and control over the identity, and making administrative decisions, basically. So, thank you. You've created your new identity, which is actually a key. Take this bit and bury it in your backyard. Take this bit and put it on your cell phone in your free software high five application, which will allow you to scan QR codes with your friends, and then the phones will send a message back to their respective boxes saying, I actually just met this person. You should now add this key. Some type of shepherding through that system so that the box can get set up and the key materials can get put somewhere safe, and the bits that you're actually using get to the right places before you're off and running.
So that's a problem that I find really interesting, is like the real world usability concerns with this type of system, where like I recently had the unpleasant experience of having actually both copies of my private key stolen, and it sucked, and my revocation certificate. So now there's like so that's something I think we have a responsibility to think about as a community. It's like, how can we get people to practice proper physical security for this material especially when people in general seem to be so alienated from the notion that digital information has a material reality and its physical manifestation matters quite a bit. So, just food for thought. No, I don't have any answer there at all.
Yeah, it's hard.
Yeah. It also seems like almost one of the central aims of what we're doing, right, is to make that more possible.
So I'll jump off that just for 2 seconds, and then we'll close the presentations, and we'll move to some more collaborative stuff. There's a thing I've been talking about. It's in some of the talks I've done in the past. Some of you might not know about it, but we believe that some of this key management stuff can be simplified primarily because the boxes are social. There's a thing we're calling the unforgettable key, which is the notion that you can take your key and break it into pieces and give different chunks of it to people that you trust, so that if they wanted to subvert you, they could all get together and do it, but none of them are going to do that because socially it's very hard to convince all of your friends to betray you. And we have a word for when all your friends get together to take over your life. We call that an intervention. And there might be times when an intervention is what you need, right? If you are incapacitated or you're in jail or something of that nature, your friends might get together to take care of you, to access your private material, to get funds from your bank account, to make sure that you are safe and all that kind of stuff. So maybe it could be good that your friends have your key, but they're not going to just get together for the purpose of betraying you, because it's socially very difficult to get all your friends to do that. And obviously, this is optional. If you don't trust your friends as a group, then you don't have to do this. None of us would trust our friends individually that much to give them our key, but as a group, we might. So we think that there's a win on the key management side for a box that has this notion of friendship built into it. I don't know if we have a solution for these physical custody issues that you're talking about, but we should try to think about whether the social aspect of what we're doing provides wins in that direction. I mean, so far, the history of key management has been one of great difficulty, and one of those difficulties is just remembering the key, and we've gotten suddenly a thing that looks a little bit like a solution because of the social nature of the box changes a lot of the analysis. So if social changes the analysis here, maybe it does in other places, and I think we should do some deep thinking about that. So
it definitely is a point where we need to imagine the threat model differently, because the key hiding for encryption in the past has always been thought of as a me against the world, secret versus potentially knowable, abstract discussion. But that's because it's been contextless. Right. When we talk about, we want to make this a platform that makes distributed social networking easy by handling some of the how do you find people anywhere questions that are currently very difficult. If, just to simplify, this box is just your distributed social network, this is your little bit of the Facebook world, then the threat model disappears with key escrow. If you have a little bit to all of your friends, and it would take some large majority of all of your friends to get together and access the material, they already have your material. The point of the social network was to share that material with all of your friends, and if all of them have turned against you, they didn't need to break your key to provide that material to someone else or to do something else with it. They had the material to start with. So the fact that they also have a key that allows you, when interacting with them in out-of-band ways, to reestablish your identity if your box is destroyed in a fire, or your physical media with the secret key gets corrupted, is not an addition to the threat model.
Right, and this also comes with social backup.
right? Of not just the key, but your materials, so you can get all your stuff back.
That's all I was going to say.
Okay, so that's just sort of an update on an old idea. I'd like to move to close the presentations. Let's move on to sort of the next thing. Maybe we should do some key signing, since it seems like we've got some folks here. Maybe we'll talk about this a little bit, but we're into the last hour of our scheduled time, and we can stay later if we want to. Okay, so big hand for Isaac and for Nic. Thank you very much for those great presentations.